because the domain or the inputs of our function and the outputs that we get, we're going to talk more about domain and range next year. Well, I say next year, it's going to be September when we come back. But you'll see that these are only true for certain domains, certain inputs. So we've got two ways of solving there. Just got 3 more equations to have a quick look at. So I'll rub these off again. Nearly there now, guys. Right, the next one, so this is C in your notes, e to the 3x plus 1 equals 8. Again, we're just going to take logs of both sides for this particular one, so I'm going to write ln e to the 3x plus 1 equals ln 8, take logs of both sides, bring this power down, but remember there's 2 terms there, so I'm going to use a bracket. So I get 3x plus 1 ln e equals ln 8. But ln e is just equal to 1. So what I get out is just 3x plus 1 equals ln 8. And then finally, I'm just going to rearrange this to make x a subject. So I'm going to subtract 1 and I'm going to divide by 3. So we get x equals ln 8 minus 1 all divided by 3. And I'm going to leave my answer there in exact form. Part D, ln x minus 5 equals 10. Now this is an equation involving ln, so I'm going to take e's of both sides. So I write e to the ln x minus 5 is equal to e to the power 10. E to the ln x minus 5, if you look at this second one here, just gives me out x minus 5. That's still equal to e to the 10. And then all I need to do is take the 5 over and I get x equals e to the 10 plus 5. Last one. The last one, slightly different. We've come across ones like this before, so let me just get rid of all of this for you. Right, last one is e to the x minus 2 e to the minus x equals 1. Right, this one, it's here. You can see I've got 1, 2, 3 terms in it. It's a bit like, or it should, if you've got an x and then a minus x, you should be thinking in your head quadratics in disguise. Yeah, these appear quite a lot now, and we've talked about them and we've shown them a few times. But this one you need to look out for. Make a note to yourself. Think about it. So I've got an x term and I've got a minus x term there. So when we've got this, you'll see in a minute why it's a quadratic in disguise. Because this e to the minus x is the same as 1 over e to the positive x. So I can write e to the x minus 2 times 1 over e to the x, or oh no, I'll put an equals there. So it's minus 2 over e to the x equals 1. So all I've actually done there is took that e to the x term to the bottom and it's underneath 2 now. Then I'm going to multiply every term by e to the x. What I get on the first one is e to the x times e to the x, or e to the x squared. The next one, when I times it by e to the x, it will cancel with the e to the x on the bottom, and I just get minus 2. There's my equals, and then 1 times e to the x is just e to the x. Now if we take everything on one side, so I've got e to the x squared minus, and I'm going to put it in right order, e to the x minus 2 equals 0. And you can see now where our quadratic comes from. So if we look again, that e to the minus x goes to the bottom, and then when we multiply through by e to the x, we get our quadratic terms. If we just use a substitution to help us, so we're going to say let m equals e to the x, it makes it easier for us to see this quadratic. I get m squared minus m minus 2 equals 0, which is very easy to factorise. You're going to get m minus 2, m plus 1 equal to 0. This gives you out two solutions here. I'll come to this side. We're going to get m equals positive 2 or m equals negative 1 from this one. Now I can put my substitution back in. So I get e to the x equals 2 or e to the x equals negative 1. Now this is the bit where you've got to look out. Here, e to the x cannot be negative. E to the x always has a positive solution. It's always above the x-axis. So there are, I'm going to just write this down here, no solutions. Now, you actually need to be, on the exam, getting rid of or show by writing it down any equations that we can't solve that there are no solutions to. If we're looking at, and we're thinking at this point in terms of the number of marks you can get, we don't want to be leaving any solutions or any equations hanging around. If we can't get any solutions from it, we write down that there are no solutions. This one, clearly there are solutions. To find x here, we're going to take ln's of both sides. So we get ln e to the x equals ln2. And then ln e to the x from here is just equal to x. So what I get out is x equals ln2 as my solution. Now the joy of this video, hopefully the camera and the picture quality is okay. The sound might be improving now. Do let me know. Give me any feedback. You know, I do appreciate it now. I'm really trying different techniques, different ways of delivering lessons to you guys. The next one will be a live one, so I'm going to do another Zoom meeting, I think, for the next one, just so I get to see you all again and chat, and also start thinking about when I'll eventually get to see you again in the classroom as well. Exercise 14G is what you can work on at the moment now. So, as before with these videos, the joy of this video is that you can stop, you can go back, you can re-watch the questions slowly, you can make sure you've got the notes, you can fill in your notes, look in your book, there's examples in your book as well of the things that I'm going through here. The key points to take from this particular lesson: 1, that e to the x